Today we're going to work on 7-7. We're solving right triangles. So in the past, what we've been doing on the last two sections, we've been using trigs, sine, cosine, tangent to find side measures of a right triangle. Again, they have to be right triangles. If they're not right triangles, you can't use this. But today what we're going to do is we're going to use inverse functions. So you're going to notice here I've got inverse sine, inverse cosine, and inverse tangent. And what they do is they help us with angle measure. Okay. So if I take a look at this one, what they want us to do is they want us to use A, and they want us to find the angle measure of that. Okay. So first of all, let's take a look at our sides and what their relations are. So if I look at this 3, how is that in relations to A? Yes. It is opposite. So this is opposite. If I take a look at the 5, how is that in relationship to the A? Yeah. It is the hypotenuse. Yeah. We've been working on that, right? So seeing that shouldn't be too hard. So if I'm looking at opposite and hypotenuse, which one of the sine functions should I use? Sine, cosine, or tangent? Sine. I'm going to use sine because remember so, ka, toa. So is opposite over hypotenuse. So I'm going to grab sine. I'm going to write down the A, and what goes in the numerator? The 3 because it's the opposite over 5, which is the hypotenuse. So right now, nothing is different from what we've done the last couple sections, correct? What makes this different is this. I need to solve for the A right here. I need to solve for that. So what we're going to do is we're going to write A equals, we're going to write inverse sine. That looks like that. I'm going to write parentheses, and I'm going to go 3 over 5 parentheses. Okay, so when you're doing your work, this is what I kind of expect you to do. So then I go A equals, okay, now take your calculators. I'm going to show you how to do this. Make sure you clear it. Make sure it's also in degrees because we want it in degrees, not in radians. Okay? Now, on your calculator, you're going to see sine, cosine, tangent. Do you see it? Okay, up above it. Do you see above each key? It's inverse sine, inverse cosine, inverse tangent. Okay. So what you're going to do is you're going to hit your second, and you're going to hit the sine key, and that inverse sine should show up. Do you see it? Now what you're going to do is you're going to go 3, you're going to go divided by, and then you're going to do the 5. And then you're going to push equals. And what do we get? 36.9? Sure. And it's degrees. So in the past, we'd say units or centimeters or kilometers because we were finding side length. Now we're finding angle, and that's essentially how you do it. Okay. Questions on that? All right. Let's go to the next one. On this one, what we're going to do is we're looking at B. How is 6 in relations to B? It's the opposite. Very good. Okay. How is 2.5 in comparison to B? It's adjacent. Are there any questions on that, on why those are what they are? Okay. So I've got adjacent and I've got opposite. Take a look at our sine functions. Am I going to use sine, cosine, or tangent? I'm going to pick tangent because I got opposite and adjacent. That's what the TOA means. So I'm going to pick tangent. I'm going to go tangent B equals. Now, which number goes in the numerator or the top? 6 because it's opposite over adjacent. And then the adjacent is going to be 2.5. Okay? Questions on that?
Can I just look at your teacher's edition for a minute?
Okay. Now what we're going to do is we're going to grab the inverse tangent. So I'm going to go B equals, I'm going to write my tangent with that little 1. That's what the inverse tangent means. You need to make sure you get that in there. Parentheses, 6 over 2.5 parentheses. Questions? Okay, so now B equals, let's grab our calculators now. We're going to clear it. I'm going to go inverse tangent. So second tangent, if you have your calculator, which you should, practice this so you know how to use it. 6 divided by 2.5 equals, what do we get? 67.4, and the label would be degrees. Very good. Yeah. Questions? All right, let's go to the last one right here. Okay. Again, I'm going to do angle C because that's what they gave me. How was 8 in comparison? Adjacent. How about the hypotenuse? 9.5? Yeah. All right. Which one do I use? Sine, cosine, or tangent? I'm going to use cosine because I got adjacent and hypotenuse. So cosine C equals, what's in the numerator? 8. What's in the denominator? 9.5. Are there any questions on why I chose to put them the way I did? Am I going too fast? Okay. So I'm going to go C equals cosine. It's the inverse cosine. 8 over 9.5. Make sure you get those parentheses. C equals, let's grab our calculators. I've got 8 divided by 9.5 equals, what do you get? 32.6 degrees. Yep. Questions? All right, let's keep going. All right, we're going to solve the right triangle and we're going to find all the missing pieces, which means we're not only going to find the sides, but we're also going to find the angles. We're going to find all the pieces. And you'll notice down here it kind of tells us what we're leaning towards, what we want to find. Okay, so let's go back up. And you don't have to use sine, cosine, tangent for all of these. Some of them you can use the Pythagorean theorem. Some of them you can use the angle sums postulate. Okay, so let's go ahead and let's look at angle A first. What could we do to find the measure of angle A? Yeah.
Use the angle sums postulate?
I can. So I'm going to take the measure of angle A plus, what's the measure of angle B? 90. How about C? And what does that equal?
180 degrees.
That's correct. That equals 180 degrees because any triangle, I add up the angles and I equal 180 degrees. Okay. It's all good. All right, the measure of angle A, E plus 111 equals 180. The measure of angle A is 69 degrees. So then I'm going to come down here and go 69 degrees. Notice how the work I have up above is very organized. It's using my algebra. And then I put the answer down below. Okay, so I'm kind of modeling how you should do that. So I got that done. Now I need to find side BC and side AC. It doesn't matter what order you find them. Okay, so which one do you want to find? You want to do BC. Okay, so right now what we're going to do is we're going to find this side. All right, and you can give them letter names if you want to, or you can just leave it as BC. I don't really care. Just if you give it a different value like X, make sure you label it on your pictures. Okay. All right. So I'm going to use this angle measure here. I'm going to use 21. I'm not going to use 90 degrees because you don't. And I'm not going to use 69. Why wouldn't it be good to use 69 with this problem? Yeah.
Just in case you got that number wrong.
Yeah, if I got that number wrong, let's say I added funny, then all of the rest of your answers are going to be wrong. And on your ACT, that could be a problem, okay? In here, I look at your work, so I'd be like, psh, no big deal. But on your ACT, they don't look at your work. They don't care, okay? So I would not look at the angle that we just found. We're going to actually use 21 degrees in C. So I've got 21 equals, okay? What are some things that I've got now? I've got 11, so how is 11 in comparison to 21? It's the opposite. And how is BC in comparison to 21? This is adjacent. So which trig function am I going to use? Tangent, right? Yeah. So I'm going to pick out my tangent, 21. Numerator, I'm going to put 11 over x or BC. I'm going to choose BC just because I am. Okay. You could put x, but then put the x in your picture. Okay, and then how do I solve for this? Yeah, multiply both sides by BC. And then divide. Okay, so my BC equals, now grab your calculators, 11 divided by tangent 21. Notice that I didn't do inverse tangent. Do you notice how I just chose tangent? Because I'm finding side length, I'm not finding angle measure. So if I do that, what do you guys get? 0.7. Yep. So I'm going to come down here and I'm going to go 28.7. And this is like units. The only reason why I put units is so that you see the difference between degrees and like side length. Okay. Questions? All right, now I need to find the third side. Now, what are some different ways that I could find the third side? Yeah.
You can take the 11 because it's the opposite, and then you can label, or like you can take AC or like whatever variable, and you can use sine because it's opposite hypotenuse.
Okay, very good. Yeah, you could use trig, couldn't you? Yeah, and you could use sine. What's another thing that we could do? Yeah. I could use the Pythagorean theorem. Now, why would I want to use the sign identities and stuff as opposed to Pythagorean theorem? Why would that be important? Ella? I chopped off my decimal. It could skew my answer. If I got that wrong, now my other answer is going to be wrong, right? So what I tend to do then is I tend to go back and go, okay, I got an opposite there. I'm going to go over here and I'm going to grab this side measure. I love what Josh says, and I'm just going to do this as the hypotenuse, and I'm going to pick the sine. I like that better. It's not wrong to do the Pythagorean theorem, but if you messed up somewhere, that can really skew your answers, okay? So I'm going to grab sine 21, and I'm going to come down here. I'm going to go sine 21 equals, the opposite is 11, and I'm going to put it over line segment AC. Okay, we're going to multiply by AC. Yeah. Then divide. Okay, so I'm going to grab 11 divided by sine 21. I've got 30.7. And then I come back up here and I go 30.7 units. Okay. Notice my work. So when I correct your assessments, I take a look at your answers and then I take a look at the work shown. Sometimes the work is fine. You did a calculator error. I assess that differently. That would still be in the A range because all you did is misused your calculator. Maybe you put in a wrong number or something, okay? But the main stuff was there. So make sure that you show what we got there. Questions on this problem? All right. Let's go to the last problem. This has a little bit different pieces missing. So what do you want to do and how do you want to handle this? Yes, sir.
I would do the Pythagorean theorem.
Yeah. Yeah, I think that's a great idea. So I had two of my sides. I could use a trig identity, but right now I'd have problems with that because I don't have any angle measures. So yeah, let's use the Pythagorean theorem. So I'm going to go RT squared, okay, plus what would be the next side? 14 squared equals 23 squared. Does the 23 have to be where it is? Yes, it does. Why? Yeah, it's the hypotenuse. Yep, it's the hypotenuse. Okay, I've got RT squared plus 14 squared gives me 196 equals, I got 529, is that right? Yeah? Okay, RT squared equals, I got 333, square root it, RT equals, I got 18.25. Notice on this, I didn't like, oh, T comes first. I got to do angle T. Got to do it first because it came first. Notice how I didn't do that. You don't have to do it in order. You can do what you're comfortable with. Especially on an ACT, I would do what I'm comfortable with first because those are guaranteed points. All right? All right, now I've got some other problems though. I've got the T and I got the S there. Which one do you want to solve for first? S. All right. Grab S. How is 23 in comparison? It's the hypotenuse. How about the 14? Adjacent. Which trig function? I'm going to use cosine. Cosine is adjacent over hypotenuse. Okay, and again, I'm trying to find angle S. So I'm going to go cosine S equals adjacent over hypotenuse. Okay, and now what do I do? S equals, because it's the angle, what am I going to write down?
Cosine, or the inverse cosine.
Inverse cosine, right. And it's 14 over 23. You'll notice it's a lot less work to find angle measures on this kind of stuff with the inverse cosine. So S equals, take your calculators, clear it, second inverse cosine, 14 divided by 23. What do you got? 52.5, and it would be degrees. Questions? Did I go too fast? Do I need to re-explain? Okay, so S, I'm going to come up here and I'm going to go 52.5 degrees. Now I got T. How do you want to find T? Yeah. I could do the angle sum postulate. I could also do what? Yeah.
Trig with sine.
Yeah, I could use
Same
trig.
angles that we just used.
Absolutely. Yep. I could definitely do sine, and I could definitely do my trig. If you have an ACT and you've got the time, or even on a test and you got time, I would do both just to make sure your answer is correct. Okay. So I'm finding angle T, the measure of angle T, plus, come back up here, I've got 90 degrees, and I've got S that I just found out. So I'm going to go 90 plus 52.5, and that equals 180. So the measure of angle T plus, I got 142.5. The measure of angle T then would be, I got 37.5. Does that make sense? Yeah? No? Yeah? Okay. So T is 37.5 degrees. And again, if you got S wrong, you just got T wrong. So maybe on the ACT you would use trig again to make sure that what you did was right. Questions? All right. Couple of definitions talking about the angle of elevation and the angle of depression. Kind of depends on what you're looking at. So if I take a look at this one, you'll notice that this side right here would be parallel to the horizon. It's the horizontal line. And notice that to do this, I'm going down. Do you see that? So this is the angle of depression. Just think depression is going down. Okay, you start with the horizontal line wherever it is, if you go up or if you go down. So this is depression. And then if I take a look at the other one, you're going to notice that this is my horizontal line and I'm going up.
So elevation.
Right. So this is the angle of elevation. It'll help you with one of your word problems that you're going to have today in the assignment. Okay. That's it. That's the end of the chapter, the last of the new stuff with trig. Okay.